So objective 6.3a, the relationship between exponents and logs. And today is just basic. How do we convert back and forth between them? And then we'll start diving into a little bit more how to graph them, how to solve equations. And then we'll get into the properties of logs. And then it'll get more difficult. So this needs to be something that becomes second nature. Here's your objective. You will be successful when you can convert quickly between exponentials and logarithms. Okay, and you can recognize common and natural logs. And when I say logs, I mean logarithms. And I'm only using 2 colors today. So if you want to just have 1 color or just maybe a highlighter or something, it will definitely be sufficient for what we're doing. Okay, so let's just see if you can remember from last year what a logarithm is. First period couldn't remember, but they were close. Pretty much couldn't remember. 5th period, someone remembered. Remembered. Somebody. No, I made it. But anyways, does anybody remember what a logarithm is? You can tell you. Well, first of all, I'll give you a hint. Has something to do with an exponential. Oh, what did you just say?
Inverses.
They're inverses. Yes, a logarithm is an inverse of an exponential. Natalie, you do me a favor and close the door. So what is a logarithm just in general? A logarithm is an inverse of an exponential. Okay. And it looks like this. You'll see the log of some number y base b equals x. And x represents the exponent. So when you solve a log, you find an exponent. Basically, that's what a logarithm is. And sometimes you're grateful that you can use a calculator and use a log to find an answer. So quickly over here, I'll just, for example, say, what if I gave you 7 to the x equals 2, and I wanted you to tell me what is the approximate value of x to 4 decimal places or something. You can't make 7 base 2. So if you convert it to a log, base 7 of 2 equals x, and put the exponent on that side, then you can plug log base 7 of 2 in your calculator, and you can calculate to 4 decimal places the value of that exponent, because the log, the answer to a log, is an exponent. Okay, so that's just the basic reminder of what is a logarithm. Let's do a formal definition. So here's the formal definition. If, that does not say if, that says ib. If b is greater than 0, so the base is greater than 0, and the base does not equal 1, same rules as exponential, then the log base b of y equals x if and only if b to the x equals y. Formal definition of a logarithm. Okay, so you can see that the answer to a log is the exponent. And they're inverses. So their x's and y's switch places. Yes. Okay. So let me just have you write this down. When you see this statement, log base b of y, here's what it means. It means what power, I'm going to put a little quote on there. What power do I raise b2 in order to get y? I almost wrote together right there. Let me clean that up. So just always remind yourself when you're solving a log, you're looking for an exponent. Okay. All right. So how to convert from exponentials to logarithmic forms. So I'm going to treat my blue pen like it's my pencil, and I'm going to treat my red pen, I'm going to use my red pen to show illustrations. So let's take the exponential. 7 squared equals 49. True statement, right? And then I'm just going to use some lines to visualize the conversion process. So we're going to start by doing, I'm going to grab my red pen. I'm going to take my base number and I'm going to drop it down into the basement. And then I'm going to travel to the other side of the equation and I'm going to come up and pass through the equal sign. So when I convert it, I write the log and put the base in the basement of 49 equals 2. So it's just drop the base down and then go to the other side, come through the equal sign to the exponent. All right. And then the way to go the other way is not a little rectangle like I just did there. Let's say we have the log base 5 of 25 equals, answer this question, what power do I raise 5 by to get 25? 2. All right, so we got that. So I'm going to grab my red pen, and here's the process. I'm going to take the 5 up, raise it to the 2, equals 25. So a little curly Q there. Take the 5 up to the second power, equals 25. And you can see that that's probably a more comfortable form of that statement, right? But I think this is really illustrating that the log of a number is an exponent. Okay. All right. So those are just the review of things we learned last year. We're going to do some converting here to logarithmic from exponential. So I'm going to grab my red pen. I'm going to put the base down in the basement and then come back through. So we're going to write log. Drop the 4 down into the basement of 64 equals 3. This is not difficult, but it does require you to practice enough that you learn it. So same thing here, drop the t down and then pass back through. So the log base t of s equals r. Now this next one, I'll get a little bit picky because this exponent right here, a plus b over a, is a quantity. So you need to use parentheses when you write it out as a logarithm. So the log base 5 of the whole exponent a plus b over a equals 7t. And I am going to be picky about you putting in a quantity around the log. Now this next one, this next one is base t, not base t. How about base 10? Base 10 is what we consider when we convert it the common logarithm. And with the common logarithm, we don't actually put 10 in the basement. We don't put anything in the basement. we just know, so there's the process. We just know that we're going to do the log, and then we're going to imaginary 10 or invisible 10 of y plus 1 equals x. I don't want to see a 10 when it's a base 10 log, because that's the common log. Everybody knows that all across the world that this is. I'm going to go with my red pen and I'm going to make a dotted 10. So you remember, it's an invisible 10. It is base 10, but don't write it. Unless you're converting the other way, then definitely write it. All right. So last one. This last one here, this one is base E. Base E is the natural log. So with the natural log, we don't write log at all. What do we write? Yeah, ln for log natural. Actually, I think it's some French term. But anyways, when we drop the base down, we don't write it. Because if it says ln, it's assumed that it's base E. So we would not write, and let me get the right color here. We would not write base E. We would assume base E because it says natural log. So again, with my red pen, I'll just go in here and do like a dashed E. On a test or a quiz, if you put base E in a natural log, I'm going to mark a quarter point off for being redundant and not paying attention to detail. Okay. Ready? Any questions about that? All right, so let's go converting the other way to exponential form. So this is the curly Q's, where we take the base and we bring it back up out of the basement. So 2 to the 5th equals, I meant to do that in blue, 32. You know what I think I'm going to do? Because I think we could get through this a little faster. I'm just going to take my red pen and go like that. First, and then I'm going to come back and write them out. Because we're converting from logarithms to exponentials. So there we go. 2 to the 5th equals 32. That's probably a more comfortable version of that statement, right? T to the P equals R. 3 to the 5th equals x plus 2. We could probably solve that. We could definitely solve that. 341. No. What's 3 to the 5th? Yeah, 3 to the 5th is 343. 343 equals x plus 2. Yeah. We could solve that one. Okay, what's this one? 10 to the 50th. We could solve that too, but would you want to write that out? No. Me either. That, yeah, I think I would write it as 1.0 times 10 to the... That's how I would write it. Forget that jazz. Okay. Let's see. Here we go. How about this one? E to the... So we could plug that into the calculator. We could solve that. How about this one? 20t equals y. Yep. And then e to the... You got it. Equals w. Now, we couldn't solve those two. Too many variables. Well, I guess if we did x's and y's, we could plug them in and graph them. It would be... Those would be vertical asymptotes, logarithmic curves. All right, so those are conversions. Now let's do a little bit of solving for the variable. Now I do want to mention this, that in your notes, I probably took it a step too far. In your homework, it'll say find the number of possible, and then it'll say, okay, the log of base 2 of 1, and that's all it says. That's it. It doesn't say equals, question mark, or anything. Anytime I have to solve a logarithm, an expression, I will say it equals x, or equals question mark, or equals something, so that I can do the conversion to the exponential if I need to, and I can see the answer. So I added this equals x equals y equals z. You won't see it on your homework. I just want you to know that that was something extra that I did, because that's my strategy when I solve these. All right. So first of all, let's do a conversion and see if we can see. Let me say it. 5 to what power equals 1?
0.
So you can hear it. That was good. So I'm going to do my conversion, right? 5 to the x equals 1. And so what do we know about that? X has to be 0. And so here's a little log property over here. When you have the log of 1, the log of 1, regardless of the base, the answer is always 0. The log of 1 is 0. Doesn't matter what the base is. Okay, so that's a log property. You might want to memorize it. The log of 1 is always 0. Okay, let's take a look at this next one. Convert. So what power do I raise 3 to get 3? So if we convert, 3 to the y equals 3 to the 1 for sure. Y equals 1. Here's another one. If the log and the base are the same, log of b, so the log is b, the base is b, the answer will always be 1. If the log and the base are the same, that's a log property. Memorize it. Next one. What power do I raise 4 to get negative 2? Can I make a negative answer on a base? You cannot. So when I say 4 to the what power equals negative 2, I say no solution. It's not possible. It's not possible. So over here you can write yourself a little note that the log of a negative does not exist. D-N-E. Does not exist. The log of a negative. Does not exist. Not even imaginary. Okay, this next one. Convert. 7 to the x equals 7 squared. Therefore, x equals, you can see it. Over here, we could write a generalized statement that says, if the log and the base are the same and you're raising the log to a power, then the answer is the power. Okay, let's take a look at this one. What power do I raise 5 to get 125? 5 to the z equals 125. Yep, some of you might see it immediately. Z equals 3. Some of you may have to rewrite 125 in base 5 so that you can see z equals 3.
On the test, we have to rewrite it?
No. Okay, how about this one? Now, these to me are the easiest ones, the base 10s. 10 to what power equals 100? 2. And all you really got to do is count the zeros on the log to determine that. 10 to the x equals 100, so x definitely equals 2. All right, how about this one? E to the what power equals e to the negative 3? E to the z equals e to the negative 3. Can you see it? Z equals negative 3, right? Because look, the bases are the same. Base e, the bases are the same, then the powers are the same. Okay, now these last two are not logarithms. They're exponentials. They confuse people sometimes because you see the word log and you think, oh, that's a log. No, it's not. The exponent's a log, but this is not a logarithm. This is an exponential. So if we're going to convert it, we're going to put the base in the basement and switch. So that's the log. Am I going to write base 10? So the log of y equals the log of 3. I bet you can see what y equals now. Yep. Same thing with this other one. Drop 3 down and rewrite. So that's log base 3 of y equals log base 3 of 8. And I bet you can see what y equals when you convert it. There it is. Okay, and let me write a generalized statement for these two statements here. If you have base to the log, same base of x, it will equal x. So the bases are the same, so the exponents are the same. Okay, so here's what you're going to do. A lot of practice. So on Canvas, the assignment, the homework for 6.3 is up, but I'll go ahead and project it, and if you want to keep up with me, I'll just keep scrolling through the problems. You are going to do problems A, C, and E for all of the following problems. Now, it's like A through G on every single problem, but I'm just going to have you do 3. You're going to do problems 2 and 4 and 10 through 16 even. It ends up being 18 problems. We've done almost 18, if we haven't done more than 18. Possibly we have. But you should be able to refer to your notes if you get stuck.